Recon is a software tool that combines seismic with well-logged data in an interactive 3D interpretation environment. Recon accelerates the geological interpretation process by allowing you to work in 2D and 3D simultaneously. Recon is positioned between seismic interpretation and 3D modeling. It focuses on introducing a three-dimensional workflow to the geological interpretation stage. You will be able to save time using Recon's Cascade technology. Cascade technology describes Recon's workflow automation processes and helps ensure that you can focus on interpreting geology as opposed to being forced to drive the software. With Recon, you'll be able to interpret faster, to improve accuracy in your reservoir model while maintaining integration with the Halliburton landmark applications and the data management infrastructure. Recon is designed to significantly increase your interpretation productivity by combining workflows from various reservoir characterization disciplines into a single integrated application, designed to help you interpret and refine your stratigraphic framework. Using Recon, you can interpret picks in 2D and 3D, map horizons in seconds, and update cross-sections instantaneously. Besides building frameworks by combining seismic and well-logged data, you'll be able to distribute well-log attributes, edit cross-section profiles interactively, and interpret and map structural horizons in 3D. Using next-generation mapping algorithms and supported by hardware-accelerated OpenGL graphics, Recon is able to recalculate all changes to your interpretations in real time. This eliminates the need for the time-consuming creation of multiple 3D models using traditional static geological modeling tools in order to investigate multiple geological interpretation scenarios. Recon's three main windows are linked, and any interpretational changes are updated in real time. For example, when you change a stratigraphic pick in the 2D correlation, the 3D cross-section view and the thickness map shown in the base map are automatically updated. The gamma ray map highlights the sand distribution for this zone. Editing a pick in 3D will quickly update the distribution in both 3D and 2D. All stratigraphic and fault data available to generate surfaces are managed in Recon's Surfaces dialog. You can interactively step through the reservoir zones by clicking on the up and down buttons in the base map view. Recon will automatically recalculate the isochore maps to show the results in 2D and 3D. Recon enables you to stratigraphically datum your displays in both 3D and 2D. You can continue to interactively edit your picks in datum mode in order to correct subtle thickness variations in your stratigraphic sequences. Recon helps you reach the optimal geological interpretation more quickly by allowing you to interactively investigate your structural and stratigraphic framework with the help of dynamic cross-sections. Using the arrow keys, you can interactively move a seismic cross-section in 3D, while Recon simultaneously updates the 2D correlation view and the base map view. You can see that all deviated wells near the dynamic cross-section are automatically associated and continuously reprojected in all views. The ability to rotate and translate the dynamic cross-section in real time will give you quicker insight into the relationship between faults and horizons in a complex structural environment. While analyzing the reservoir framework, you can make changes to your interpretation in any of the three windows showing the dynamic cross-section. This example shows the real-time speed at which Recon can project wells onto a dynamic cross-section which is dragged through a reservoir. The ability to quickly rotate dynamic cross-sections prevents you from having to predefine multiple strike and dip-oriented static cross-sections. This cross-section shows several onlapping horizons. Using Recon's Cascade technology, simply dragging and dropping the pix immediately updates the dynamic surface terminations that you have defined in your stratigraphic framework. Recon is integrated with the Halliburton Landmark data management environment. Recon is directly connected to SizeWorks, enabling you to animate through SizeWorks datasets without the need for converting or importing SizeWorks volumes. You can load ASCII LAS well log curve data and deviation surveys into Recon using intuitive data loading wizards. Recon also has wizards for the ASCII import and export of pix, grids, and intervals. Wells, curves, pix, grids, intervals, and point sets are directly accessible from the OpenWorks database. You can display and edit SizeWorks horizons and fault segment points interactively in both 2D and 3D. Recon has 16 different ways to display a geological cross-section in its interpretation section view. You can interpret surface and fault pix, interwell pix, and intervals in these cross-sections. You can switch from flip spacing to true XYZ spacing with a single mouse button click. Horizon and fault surface profiles can be displayed together with zone fills and well log templates. Any cross-section can be stratigraphically datumed, and you can continue to drag and drop pix in the datum mode. You can show true stratigraphic thickness cross-sections as well as sections showing projected deviated wells. Seismic cross-section backdrops combined with directional wells are displayed with a single mouse button click. This example Recon project shows BP's North Sea Makar field. Well log templates showing multiple well log curves and pix are combined with an animation of seismic data through a SizeWorks volume. The SizeWorks horizon is displayed tied to the well pix. The entire 3D view is now stratigraphically datumed on the Thor formation. Recon correctly shifts all well log trajectories, horizons, and seismic displays relative to the datum. You can continue to slice through the seismic volume in datum mode. You can quickly change a Makar cross-section from fixed spacing to true XYZ spacing mode. The seismic shown on the cross-section is directly accessed from SizeWorks. Datuming the horizon actually applies the stratigraphic shift to the entire 3D project, correctly shifting the deviated wells together with the seismic. This datum cross-section mode lends itself well for the interpretation of subtle stratigraphic traps. Editing a pick in datum mode automatically regenerates the displays in both 2D and 3D. Incorrect well log curve data values can be quickly cleaned up in Recon using its data cleanup wizards. More complex log curve calculations can be performed using Recon's free-form equation-based calculator. You can tie a seismic horizon to well log pix in a single step. Note that in this example, the depth-converted seismic horizon does not honor the well log pix. Using a single-step conformable gridding technique, Recon automatically calculates a correction isochore which is used to tie the seismic horizon to the corresponding pix in the wells. Tying a seismic horizon to its well pix can often highlight significant interpretation errors in the well log pix database. By simultaneously displaying a difference grid between the original SizeWorks horizons and the pix-based horizon in the base map, you can easily identify the incorrect pix and fix the interpretation in either 3D or 2D. Recon dynamically regrids the horizons, and the base map difference grid is automatically updated to show the correction. Applying a recursive conformable gridding relationship to all surfaces in your stratigraphic framework is a one-step operation. Recon honors the conformable relationships while you are continuing to interpret, saving significant time when interpreting multiple scenarios. You can distribute well-log attributes such as porosity and permeability for any zone. Applying a log attribute cutoff quickly highlights reservoir continuity and connectivity problems caused by incorrectly interpreted pix. Using Recon's Cascade technology, you'll be able to quickly resolve these problems by editing your interpretation. Recon automatically takes care of all the intermediate steps needed to correct the porosity distribution in 3D. At any time during your interpretation, you can highlight the filtered well-log attribute distributions by interactively stepping up and down through the reservoir.